Problem 53 asks us to use the table below to write the rule. Okay, well, we need to look at this table. There's something tricky about this table. It's not in order. In order to find the rule, we need the table to be in order. So let's put it in order. We have x and then y. Okay, what is our smallest x value? Our smallest x value is going to be -1. So when x is -1, y is -1. Okay, and what comes next? For counting by ones, x is 0, y is 2. And then when x is 1, y is 5. When x is 2, y is 8. When x is 3, y is 11. Now you'll notice that I haven't entered these numbers yet. We'll talk about those in just a minute. Let's see if we can make a rule without those first. So each time x goes up by 1, how does y change? Well, to get from -1 to 2, we had to add 3. Let's see if that holds steady. From 2 to 5, we added 3. From 5 to 8, we added 3. From 8 to 11, we added 3. So that rule holds. Now, let's put in these partial points. They're not equally spaced out. They're in between. So let's see where they would fall. 1/3 is 1/3 of the way from 0 to 1. So when x is 1/3, y is 3. Well, let's see if this makes sense. If we go from x being 0 to x being 1, it increases by 3. Well, we went 1/3 of the way. So we broke that apart. And 1/3 of 3 is 1. So 1/3 of that jump, it went up by 1. It makes perfect sense. It follows the pattern. When x is 1.5, that's halfway between 1 and 2. Half of a 3-point gain would give us a 1.5-point gain. Well, 5 plus 1.5 happens to be 6.5, which is exactly what's in our table. So it makes sense that these would fall in our table. I don't try to evenly space them out because they're not a full change in x. So they need to go into the table where they fit. Okay, let's make our equation. So we have y equals mx plus b. M is our slope. It's our growth factor. We've figured that out fairly thoroughly. So it's 3 because y increases by 3 every time x increases by 1. We put our x plus b. B is our starting point. B is our y when x is 0. So when x is 0, y is 2. So the equation of this line is y equals 3x plus 2. Problem 54. The scatter plot below displays the average annual pay for a given number of years of education. A line of best fit for the data is also graphed on the scatter plot. Use this information to predict the average annual pay for 12 years of education. Okay, let's look on our graph. Years of education is on the x-axis, and average annual pay is on the y-axis. So we look at years of education. We want to find the average annual pay for 12 years of education. Let's identify 12 years of education. It's right here. So let's follow it up. We're right here. So we need to follow that over. And determine what the average salary would be. Now, if you notice, it was right above the line. And by line, I mean the grid line. It's right above the 30,000 mark. So somewhere a little bit above 30,000, but significantly below 35,000. So if you were to say approximately 31,000, approximately 32,000, those are legitimate answers based on this graph. It's not the best graph, so these would be acceptable answers. Now, if you had a multiple choice, you wouldn't have both of these, so you would pick the one that was there. Okay, Miss Hollis is driving from Louisville, Kentucky to Panama City Beach, Florida. The trip is 650 miles. If she averaged 65 miles per hour for 6 hours and 60 miles for the remainder of the trip, how long was her total trip, rounded to the nearest hour? So let's see. She has 650 miles. She averaged 65 miles per hour for 6 hours. So 65 mph for 6 hours. And then 60 mph for the remainder of the trip. So for the remainder of the trip, so we're going to say X hours. How long was her total trip rounded to the nearest hour? 650 is her total trip is equal to 65 times 6 plus 60 times X. Okay, so 650 is equal to 65 times 6. We can do this relatively quickly. 65 times 6. 6 times 5 is 30. 6 times 6 is 36. 390 plus 60x. So let's subtract 390 from each side. Well, if we subtracted 400, that would be 250. So we're going to have 260 since we only subtracted 390. And that's going to equal 60x. Okay, so let's divide both sides by 60. We have x equals, well, how many times does 60 go into 260? We need to calculate that. So 60 does not go into 26. Well, but 6 goes into 26. So let's see how many times 6 goes into 26. It goes in there 4 times. So that would be how many times 60 would go into 260. And that would be 240. So we bring down our 2. Okay. And then we're going to bring down a 0. 6 goes into 200. 60 goes into 200 how many times? What's going to go in there 3 times? It's going to be 180. And then we're going to bring down, we're going to have 1 left over. 3. Now 20 left over. So we know that we have a third. So it's 4.3 repeating. So x is 4.3 repeating, or 4 1/3. We want the total number of hours, so we have to say her 6 original hours at 65 miles per hour plus her 4 1/3 hours. Let's move over our hours here. That gives us 10.3 repeating hours total, or 10 1/3 hours total. But be careful, it did say rounded to the nearest hour. So 1/3 is less than a half. So her total trip would be approximately 10 hours. Susie went to buy some CDs. The store was running a sale of 15% off of all CDs. Write an expression that Susie could use to find the sale price of a CD if P is the original price. Well, it's 15% off. So we know that anything, the original price is 100%. So 100% be 1.00 minus 15% would leave us with 85% of the original cost. So she could have 0.85p. That's how much the final price would be. Or she could have p minus 0.15p. The same idea. This is 1p minus 15% of what that p is. It is actually equal to 0.85p. But we only want an expression. So either one of these expressions is perfectly acceptable.